So we have the inverted differential amplifier circuit with the input voltage, the output voltage, and an ideal operational amplifier. So how do we calculate the feed-forward factor, which is the differential voltage divided by the input voltage when the output voltage equals 0? Well, for this case, we can imagine this path to be just a short circuit. Our differential voltage in this case is just the voltage from the positive to the negative input of the differential amplifier. So for the input voltage, we can go this loop over the resistor 1 and the resistor 2 back to the ground. So what we get is that the input voltage is the voltage over the resistor 1 plus the voltage over the resistor 2. But the current that flows through the resistor 1 is the same that flows through the resistor 2, because no current can flow into the operational amplifier because we assume it to be ideal. So what we get is that the input voltage is just the current times the resistor 1 plus the resistor 2. For the differential voltage, we can go this loop over just the resistor 2. So what we get is that the differential voltage is minus the voltage over the resistor 2. So if we write it down, we get this ratio, and the current just cancels out because it's the same. If we calculate the feedback factor, which is the differential voltage divided by the output voltage when the input voltage is 0, we can just imagine this path to be a short circuit. So for the differential voltage, we can go this loop to ground, and we get that the differential voltage is the voltage over the resistor 1. For the output voltage, we can go this loop over the resistor 1 and 2. So we get that the output voltage is minus the voltage over the resistor 1 plus the voltage over the resistor 2. So if we write that down, we get this ratio, and the current just cancels out. The voltage gain of the overall circuit is minus the feed-forward factor divided by the feedback factor, which in this case just would be that. But the resistor 1 plus the resistor 2 just cancels out, so what we get is that we have minus the resistor 2 divided by the resistor 1. So the output voltage of the overall circuit is minus the resistor 2 divided by the resistor 1 times the input voltage. And now we can see why it's called an inverted operational amplifier. It's because it's a minus. And if the input voltage would look something like this, the output voltage would be inverted and would look something like that.